Hi, now I am going to start my another video regarding flight fare prediction. Okay, I am going to start my screen. In previous video, I have done all pre-processing part in using the train set.slx. Now it's time to pre-process the test xlx seat. Okay, so first of all, I have to check all the attribute of the test data, and the attribute of test data is the same of the train data, only the price column is missing here. Okay, now I have to pre-processed. Here I have just copy and paste that things I have done in previous. I have just copied from previous and pasted here. Okay, same. I have to convert it date of journey into day and month format. I have to convert it also the departure time, the arrival time, the duration, and all other. I have dropped also. I have done everything that I have done in previous. Okay, I have just copied and pasted here. Now I have to again check the head after my pre-processing part. Next I have to check the total column. See, all column has situated except the price column. Okay, here I have done the very important task, that is I have splitted the data into X and Y. Here in X I have mentioned all that is total stop, journey day, journey month. I have mentioned all over the column. I just copied and paste it over here. I have mentioned all over the column. I have just copied and pasted over here. Okay. Now I have assigned into the X variable. After done that, I have also assigned the data into the Y variable. Okay, and there is another question maybe come to the everybody's mind, that is why I have done train data and test data and have pre-processed those data in separate way. Is it possible to add two data, train and test, and done pre-processed simultaneously? Is it possible? Yes, it is possible, but it is possible only where I have participated in Kaggle competition or some other hackathon. But when the code will use as a deployment purpose, the code will use the in the client purpose. Okay, in that case this is not the way. See, I have here, I have done the train and test pre-processed simultaneously. The data leakage comes into the picture, and the data leakage is very, very dangerous. Here, the test accuracy is very good, but when you have to test, the train accuracy is very good, but when you have to test with another value, the accuracy is very, very less. That is the overfitting condition. That is the overfitting condition. What is the overfitting condition? Low bias and the high variance. Training accuracy, when I have tested, when I have trained my data with training data, the accuracy is very, very good. That is the, but when I have to test it, I have to test it with my test data, the accuracy is very, very low. That is the low bias, high variance condition, and this is the overfitting. Training accuracy is very high and the test accuracy is very low. That is the low bias and high variance condition. You have checked here. What is overfitting? Low bias and high variance. Yeah. A model that exhibits small variance and high bias with underfit the target while a model with high variance and little bias, that is low bias, with overfit target. Okay, low bias and high variance. We have to avoid that condition, that is low bias and the high variance. Low bias and high variance. That's why I have not done the training data and test data pre-processing part simultaneously. I have first completed training data pre-processing part, then I have pre-processed the test data part. I think it is clear, all of you. Next, the dependent feature I have already assigned in y variable, and my dependent feature is, we all know, that is the price. Okay, now I have to done the another important things, that is the feature selection. Why I have used the feature selection? Because feature selection finding our best feature which will contribute and have good relation with target variable. Okay, we have to know, is it highly correlated or the less correlation between the target variable and the other feature. Some of the feature selection method are heat map. I have used here the heat map, feature importance, and select k-best. Now, first of all, I have done, I have done the visualization part I have done the visualization part. Here see, the value is towards green, that is the highly correlated with price data, that is the total stop. Total stop is highly correlated to the price data, and these are towards the red value, towards the red. It actually the negative correlation. It has denoted the negative correlation. Here I have done the another important task. See, first of all, it has created problem. There is too many same kind of data. Same kind of that data shows that data actually show the same kind of correlation. 80-90% of 80 or more than 90% sometimes data is has actually described the same kind of correlation. Here I have written both independent feature have done same kind of task. That's why I have used the extra tree regression. Using extra tree regression, identify which are important feature. The data duplication is not important, but it is not the way. Data duplication is not the way. So if two independent features are correlated, if two important independent features, suppose the total stop, that is the independent feature. This is highly correlated with my target variable. Okay. And journey date, it is also the highly correlated with my target variable. Okay. If two independent features are correlated somewhere around the 80 to 90%, so drop one of the independent feature because those of independent feature to the same kind of task. I have told again, the same kind of task or the data duplication is not required or not, it is the good way. That's why I have used extra tree regression. Using extra tree regression, we easily identify which are important feature. Using extra tree regression, we have easily identified the important feature. That's why I have written that code from sklearn.ensemble import extra tree regression. I have imported extra tree regression from the sklearn ensemble module. I think it is clear, and I have assigned selection the extra tree regression, and I have to fit it the data. Now see, and I have to print the feature importance. Here I have to visualize that things. The total stop, here see it very carefully. The total stop is the most important feature. The total stop are playing most important role, and it is the most important feature. Okay, the total stop is the most important feature, and it is the highly correlated to the target variable, that is the price. I think it is clear. Total stop is the highly correlated. I have to visualize, and the total stop is the most important feature, and total stop are playing the very important role to predict the important feature. Okay, next I have done the train, test and split, and here my training data is 80%, my test data is the 20%. That's why the 0.2, and random state is 42. I have used the random forest regression. I will discuss all of this, why I have used random forest regression and why I have done the hyperparameter tuning, and after the model, what the step is important, I will discuss in my next video. The next video will come soon. Thank you, and keep learning, keep exploring. I am also learning and also trying to exploring the new things of data science, especially the machine learning and deep learning.